What's poppin', dogs? Mr. Allen here with some graphing in polar. We're going to graph r equals 2 minus 5 cosine theta in this video. Now, the first thing I like to do when graphing in polar is figure out what kind of graph I'm dealing with, right? Is it a circle, a rose? Is it a cardioid, maybe a limacon, right? I'm dealing with a limacon in this one here. How did I know? Well, these two numbers are different. If they were the same, it's a cardioid. When they're different like this, it's a limacon. Now, the other thing that we need to figure out here is, do we have a loop in this limacon? Well, the way I know, I feel like I'm really going for it with the limacon, is if this number here is bigger than this one, we are going to have a loop, okay? It'll work itself out there in the T-chart, kind of, sort of, but it's good to remember that we are going to have a loop in this limacon. Now, there's different ways of plotting these things or graphing them. You don't have to use a T-chart. I like to use the T-chart. Some people memorize all sorts of patterns. I get confused with that, okay? So I'm going to go the T-chart method. If you don't like that, find another video because I'm going to T-chart it up. All right, so first thing we do is we plug in our theta here. We kind of go backwards in polar here. We put in this side of the T-chart to figure out my radius, right? Different than the Cartesian XY coordinate system. But if I do 0 here, cosine of 0, that's 1, right? 1 times 5 is 5, so we have 2 minus 5, which is negative 3. Now, pi over 2, cosine of pi over 2 is 0, so we're just going to have 2, right? Because 5 times 0 is 0, 2 minus 0 is 2. Then I got pi, okay? Well, cosine of pi is negative 1. Negative 5 times negative 1 is positive 5. 2 plus 5 is going to be 7. Then we have 3 pi over 2, which is 0 for cosine. So we're back to 2. And then 2 pi is positive 1. So we're back into the 2 minus 5 situation, which is negative 3. And you will see that with these cosines where it's like symmetric kind of thing going on, right? Now, let's go ahead. Let's plot this thing. Because it's cosine, it should be going in the x direction, right? Because cosine is my x coordinate on that unit circle. If it was sine, we'd be up and down with this thing. And because it's negative, we should see the longer part going over here to the left. Let's see if that all works out. Okay, you don't have to memorize that. It will work that way out, you know, with the T-chart, but it's also nice to like double check yourself. So for 0, I have negative 3. So if I'm at 0, instead of going to positive 3, I'm going to go to negative 3. Or reflect over, right? 3 is here, reflect over because it's negative. Then I have pi over 2, so this way, and it's just up 2. Then we have pi 7, which is all the way over here. And then for 3 pi over 2, it's just 2. And then for 2 pi, which we're back over here, it's negative 3. So instead of being here at positive 3, we would reflect over back to that point right there. Okay? Now with these, they will pass through the origin as well. That's how you make this loop, okay? The loop is tricky, man. I'm going to be honest. The loop is kind of tricky. You got to really plan yourself out as to how you're going to go. I'm going to start here. Let's see if I can get this in one swoop. So I'm going to do like this. Then I'm coming back up here. Oh, that was kind of terrible. All the way around. We don't want it to be pointy here. Back on. Oh, my goodness. That actually turned out okay. That turned out pretty good, okay? So the loop, you got to pass through the origin to make that loop happen. As you can see when I was saying, like, oh, if it's going to have a loop, like, it'll work itself out in the T-chart. How else would I really, I guess I could have come way over here, but it would have looked weird. So it works itself out with the T-chart a bit, especially, or reminds you that there could be a loop there. But everything checked out, right? We did say because this was negative, it should be going in this direction here. Whereas if that was positive, my ordered pairs would have worked out where it goes over in this direction instead, okay? So there we go. A lovely little graph of a limacon, right? Cool. Now, if it were sine, we'd be going like up or down, right? Do you want to try a sine one real quick? Let's try a sine one. Right on here, okay? We're gonna do the same one here, but we're gonna see how it works out with sine instead, okay? So now I'll have r equals 2 minus 5 sine theta. So based on what we're talking about, it should go down, right? It should go down. So let's fill out our T-chart here for the sine. We got r, we got theta, 0, pi over 2, pi, 3 pi over 2, and 2 pi. So when I plug in 0 for sine, I get 0. So r is going to be 2. And when I plug in pi over 2, that's positive 1 on my unit circle. So 2 minus 5 is negative 3. When I plug in pi, sine of pi is 0. So we're back at 2. Sine of 3 pi over 2 is negative 1. So now I have 2 minus 5 times negative 1. Negative 5, negative 1 is positive 5. plus 2 is 7. And then we're back at 2 pi. Sine of 2 pi is 0. 2 minus 0 is just 2. So knowing your quadrantals of sine and cosine is of paramount importance here when graphing in polar if you're using the t-chart, which I prefer. I don't like to memorize little things, but I am good with remembering my, quadrantals, and also my specific trig values are always good as well in my unit circle. Right? All that stuff super important, comes back in polar. So now let's plot here. We got 0, comma 2, so we're going to be right here. We have pi over 2, so rotate up, but we're at -3, so we're going to be all the way down here. Boom. And then I've got pi and then 2, so it'll be right here. And then we're at 3 pi over 2, 7, all the way down here. And then when we're at 2 pi, we're back at 2. All right, so the same kind of situation, just rotated, right? So we got to pass through the origin again, and we're going to have to try for this loop. I'm trying to think about how I want to do this in my head. Okay, I'm going to come down like this, loop through, all the way back on down. Try not to make it too pointy. I got to plan ahead to get back to that origin. Woo! That's a Limacon right there, man. That's what I'm talking about. And it's fun to say, Limacon. I might not be pronouncing that absolutely perfect. I might be going too hard on the accent, but I'm having fun with it. I hope you guys are having fun with it. Polar graphs are kind of cool. Definitely different thing here, but take some practice. Practice makes perfect. Otherwise, you guys have a great day. Okay, thanks for tuning in. Thanks for watching the second bonus example here. That was fun, and have a great day.